Throughout history, guarding your military position has long been the difference between winning and losing any conflict. It's good to know when your enemy is approaching your location so you can prepare to defend your position. The obvious way to achieve this is to post lookouts or sentries. These options do not come without risks. For example, sentries being distracted, falling asleep, or too few people to cover an area. In old westerns, cowboys were often seen to put their ear to a railway track to hear if a train is coming. This is because the speed of sound waves depends upon the material through which they are travelling. Sound travels 15 times faster through the metal railway tracks than through air, giving the cowboy an early warning of the train's arrival. Putting your ear to the ground to listen for footsteps, often depicted in movies showing Native American Indian trackers, really was not the solution though, and rarely worked in ordinary ground. Detection systems for seismic events was used long before the military made use of the technology. Indeed, the first seismometer was made in China during the 2nd century, with the first Western description of the device coming from the French physicist and priest Jean de Hautefeuille in 1703. The more modern type of seismometer was developed in the 19th century. These, of course, were meant to warn against and then measure earthquakes. In this video, we will look at the British Tobias system and how it came into being. The Americans were really the first to build systems which exposed troop activities. They used a system developed by Texas Instruments which would pick up on the disturbance of the ground and would alert those monitoring it. The PSR-1A is a Vietnam-era seismic sensor designed to detect ground vibrations. It uses wires between the geophones and the box. There are 4 separate inputs, and each of these can have several sensors. The first British combat use of seismic-based systems seems to have been in the mid-1960s in Indonesia and Borneo, using US-supplied equipment. The US-made Texas Instruments X150A was a commercially available seismic detector based mostly on the PSR-1A, which consisted of special seismometer microphones placed into the ground and connected by wires to a common control unit. An operator, using headphones linked to this system, could monitor for tiny vibrations in the ground. Typical sensitivity was a radius around each sensor of 30 meters for footsteps or 100 meters for vehicles. It did not enjoy more widespread deployment, principally because the whole setup was not very rugged and somewhat cumbersome. Hence one of the reasons for the British Army to turn to developing their own military-grade products. The British Tobias system was developed by the Radar Research Laboratory and produced by Elliott Automation, part of GEC Marconi. It came into operation in 1969 and was used operationally straight away in several conflicts. The seismic sensors would be purchased as a normal commercial product from the Geospace Corps in America. As a result, it meant that the sensors would not be included in the case the Tobias system would ship in. There were 3 models of control unit. The Mark I was made from fiberglass and the Mark II and Mark III from alloy. There were some minor changes between the different versions, but the most extraordinary feature was that so little effort went into protecting the 3 flimsy wires from the battery container in the lid to the terminals on the main control panel. The lid was heavy with the weight of the batteries, so when opened it tended to fall. It was so easy for the wires to become detached and easy to make an error in connecting them up again. The batteries were 8 1.5 volt U2 cells, arranged to give both 9 volt and 3 volt power outputs. The equipment was made at Boreham Wood, but was maintained by the Aviation Service and Repair Division at Rochester. Detection of intruders could be done via both visual indications and audio feedback. A headset for listening was included in the additional equipment, and D10 wire would be fed out from reels to connect to wires on the sensors. The sensors could be painted either brown or green and had a 3-inch spike attached. In the event of a trigger, the gauges would read the movement and audio warnings would be generated. This, of course, did nothing to stop the enemy, but it gave you both a warning of an attack and the chance to go and investigate the cause. Training on the equipment was done at the School of Infantry Support Weapons Wing, Netheravon, although there may have been training at other sites also. A manual was made for training. Tobias devices were used in Northern Ireland and deployed to assist in covert detection and observation, especially in and around border areas. One account stated how they could sometimes be found in the back of a Humber pig and used to protect makeshift observation posts from unwanted visitors. It appears in true British Army form there were some misgivings about the equipment and little care was taken to guard against damage. The equipment is now no longer in use, but was certainly used in the First Gulf War, including protecting bases in Cyprus and into the 1990s. Information on the Tobias equipment is thin on the ground, and we have used the training manual and other information gathered elsewhere. To eliminate the need for continuous monitoring and at the same time to provide an effective intruder warning system in areas of high seismic activity, urban areas, industrial estates, etc., Elliott Automation developed ADA, an automatic intruder alarm system. Again, seismic sensors are used, which may be deployed singly or in arrays buried in the ground. The display console, which can be mounted on racks in a guardhouse or other building, can be set to provide an automatic alarm signal with outside movement. They have since been replaced by Platoon Early Warning System, or PEWS for short, such as the Hermes Monitor Unit and more recently a Battlefield Anti-Intrusion System, BAIS system. Another system developed was one called IRIS, or Infrared Intruder System. It was developed by GEC AEI Electronics Limited for use with the British Army. This worked as an infrared system rather than using ground disturbance. This system apparently had a smaller overall range than Tobias, but was thought to be more accurate and suited to being used in buildings, roads, gateposts and concrete structures. The basis of the system is an infrared beam projected between a transmitter and a sensor. Interruption of the beam causes an alarm to be triggered at a remote monitoring unit. The beam is extremely narrow and it is virtually impossible to detect without interrupting reception by the sensor. The effective part of the beam is a narrow cylindrical pipe about 40 millimeters in diameter connecting the transmitter and sensor, which must be completely obscured to give an alarm. In particular, the transmitter and sensor may be hidden in light foliage amongst or behind small twigs and branches. IRIS can be used both during the day and at night time over ranges of 200 meters in average conditions. Even in snow, fog or tropical rain, a range of 50 meters may be obtained. Information on this equipment can also be found in the training booklet called Radar and Surveillance Devices Intrusion Alarms. The system is designed to be fail-safe in that damage or destruction of either transmitter or sensor, disconnection of the battery, or the cutting of the signal cables leading to the monitor will automatically indicate an alarm condition. It can be powered from any convenient 12-volt supply. Delay circuitry has been built in to overcome false alarms such as birds flying through the beam. It was suggested in the training manual that both Tobias and IRIS are used together to improve the coverage. Today, Tobias and IRIS systems are one of the more unusual collectibles, and many post-war collectors do not understand the importance of such equipment. We hope you have enjoyed this delve through the electronic military intruder world. Please don't forget to give us a thumbs up, and to watch more content like this, please don't forget to subscribe.